Today we're going to be learning 4.3, which is about isosceles and equilateral triangles. We learned in 4.1 the classification of these. We know that an isosceles triangle is a triangle that has two sides that are equal, and an equilateral triangle is a side that has all sides equal. We're going to learn a couple other facts about them. So first up, we have an isosceles triangle. All right, isosceles triangle actually has different types of parts. So the first part is the legs. All right, the legs are the congruent sides. So we're in our picture over here. I would say our isosceles triangle AB is going to be congruent to BC. We show congruence by making a little tick mark or multiple tick marks. So our legs, our legs are AB and BC. All right, we also have these things called base angles. Base angles are the congruent angles across from the legs. So that they're congruent angles across from the legs. So look at this. If I look from across the leg, so my first leg was AB. Across from that would be angle C. So angle C is a base angle. The angle across from side BC, would be side A. So angle A and angle C are your base angles. And then finally, your vertex angle. Your vertex angle, the vertex angle is the intersection of the legs. All right, so it's where your two legs meet. So in this picture, our two legs meet at angle B. So that would be our vertex angle. All right, so we have our legs. This is a leg. This is a leg. This is our base. This is our vertex angle. And angle A is our base angle. And angle C is our base angle. All right, so when I refer to a leg or a base angle, this is what I'm kind of talking about there. So first thing here, we have the isosceles triangle theorem. It says if two sides are congruent, then the angles opposite those sides are congruent. So it says if two sides of the triangle are equal. So if we look at the diagram of if, we said if AB, side AB, is congruent to side BC, all right, then the angles opposite of those sides are congruent. So the angle opposite of side AB, we said was angle C, is congruent. The angle opposite of BC is angle A. So now we know that the base angles are equal. The next one says the converse of isosceles triangle theorem. This just means, converse just means you flip the if then. So we're going to switch what we said before. And so now we're going to say if angle C is congruent to angle A. So if those base angles are the same, then we can assume that the sides, or those legs, are going to be congruent as well. And we're going to be using these facts to help us solve more algebraic problems here. Example 1, it says find the angle or the measurement of triangles of the triangle's angles given that BC is the same as BA. So we know that those two sides are going to be congruent, so we can mark that. Which means if those two sides, those legs are congruent, the base angles or the angles opposite of them should be congruent. So we know that angle C should be the same as angle A. So we can set those two angles equal to each other. So 4x plus 5 equals 5x minus 10. And we can solve for x now. I would add 10 to both sides. So I've got 4x plus 15 equals 5x. I'm going to subtract 4x from both sides, so I have 15 equals x. All right. Now what it wants to do is it wants us to find the measurement of the triangle angles. We're going to plug that in. So 4 times 15 is 60. 60 plus 5 is 65. So this is 65 degrees, which makes this angle 65 degrees. We could also find angle B now because we know a triangle adds up to 180. So I can say 180 minus 65 minus 65. All right, and that leaves me with angle B being 50. So we can kind of use what we did in 4.2 to kind of further that. Example 2 says, find the legs of the triangle. So here, if we look at this picture, it tells us that angle S and angle T are the same, which means we can assume that angles, or the sides opposite of those, are going to be congruent. The side opposite of angle T is this one right here, so I'm going to put a congruent mark. The side opposite of angle S is right here, so I put a congruent mark here. So we know that those two sides should be equal, so I can say 3x minus 13 equals 2x. I'm going to subtract 3x from both sides, divide by -1, and I get x is 13. They want us to find the length of the legs. We're going to plug that back in. 2 times 13 is 26, which makes this side also 26. Last one here. It says, find the value of x. The markings tell us, they tell us that PR is the same as PQ, which means that those sides are the same, the angles opposite of them should be the same. So the angle opposite of PR is 2x. The angle opposite of PQ is R, and we don't have anything there, but since we know they're the same, we know that this is also going to be 2x. So now I can say 40 plus 2x plus 2x equals what? That's a triangle. What do the angles in triangle always add up to? They always add up to 180. So I have 4x plus 40 equals 180. I'm going to subtract 40 from both sides. So I get 4x equals 140. Divide both sides by 4, and I get x is 35. Awesome. Oops. Sorry, guys. All right, example 4. This one, we've got a ton of different triangles going on here. It says, if BE is congruent to BC, name two congruent angles. So here's BE, and here's BC. So they're saying that these two sides are going to be congruent, which means the angles opposite of them in that triangle there are going to be congruent as well. The triangle we have here is triangle BCE. So I would say the angle opposite of BC would be this angle right here. That angle right there looks like that is angle BEC is congruent. All right, the angle opposite of BE is this angle right here. That looks like that is angle BCE. Awesome. All right, the next one says angle CED is congruent to angle CD, or CED is congruent to angle CDE. Name two congruent sides. All right, so let's see. CED, C to E to D. All right, so this angle right here is going to be congruent to C to D to E. So this angle right here. So this angle is the same as this angle. So the sides opposite of those should also be equal. So the side opposite of CED is side CD is congruent to the side opposite of CDE is this one right here, and that is side CE. All right, and that is it for isosceles triangles. Now we're moving on to equilateral triangles. All right, equilateral triangles, we know that an equilateral triangle means all the sides are equal, which also means all the angles are equal. So all the sides are equal and all the angles are equal. So it says, if all the sides are congruent, then each angle measures 60 degrees. They're all congruent. All right, so in example 5, look at the markings they tell us. It says that all of the angles are equal, which means every single angle here is 60 degrees. If all of the angles are equal, that means all of the sides are also equal. So I know that this side's the same as this one, which is the same as this one. My goal is to find x, so I need to make an equation somehow. And if I look at that, I know GJ is 6x minus 5, and GH is 5x. So if I have both of those sides and they have to be the same, I can say my equation is 6x minus 5 equals 5x. I can subtract 6x from both sides, so I get negative 5 equals negative x. Divide both sides by -1, I get x equals 5. All right, it also wants us to plug it back in, so it wants us to find all the sides and all the angles. We already know the angles are 60. If I plug that x back in, 6 times 5 is 30. 30 minus 5 is 25. And since it's an equilateral triangle, we know every single side is going to be 25. All right, example 6. This one says that these two angles, right, or two sides are equal. All right, so this is an isosceles triangle, which means that this isosceles triangles, the angle opposite of them should be equal. So this angle should be the exact same as this angle. But we don't know what those are, so we're going to figure that out. I know I've already used up 60 degrees in this triangle, so I know I have 180 minus 60, which is 120. So I have 120 degrees to use up between this angle and this angle. Now I know they have to be equal, so I'm going to do 120 divided by 2, and I get 60 degrees. So I know that this angle is 60 and this angle is 60, which means this isn't actually an isosceles triangle. It's actually an equilateral triangle, because if all the angles are the same, that means all of the sides are the same as well. Which means I can do 3x plus 8 equals 4x minus 4. I'm going to add 4 to both sides. And I'm going to subtract that 3x. And I get x is 12. I'm going to plug that back in. So 3 times 12 is 36. 36 plus 8 is 44. And since this is an equilateral triangle, I know all the other sides are 44 as well. Last problem here. All right, this one says, it tells us that all of the sides are equal, which means all of the angles are equal, and that every single angle is going to be 60 degrees. So if you notice here, T, I have 2 markers. I said it was 60 degrees, and I also said it's 3x squared, so I can set those equal to each other. I'm going to divide both sides by 3. Now I want to find what x is, and currently I have x squared. To get rid of x squared, or the opposite of squaring, is square rooting both sides. So we're going to take the square root of both sides. The square root of x squared is just x. All right, when we take the square root, we have the positive and the negative option.